let's say that I've got a triangle, and this side has length b, which is equal to 12 units, or whatever units of measurement we're using. Let's say that this side right over here has length c, and that happens to be equal to 9, and that we want to figure out the length of this side, and this side has length a, so we need to figure out what a is going to be equal to. Now, we won't be able to figure this out unless we also know the angle here, because these things could be, you could bring the blue side and the green side close together, and then a would be small, but if this angle was larger, then a would be larger. So we need to know what this angle is as well. So let's say that we know that this angle, which we will call theta, is equal to 87 degrees. So how can we figure out a? And I encourage you to pause this and try this on your own. Well, lucky for us, we have the law of cosines, which gives us a way for determining a third side if we know two of the sides and the angle between them. The law of cosines tells us that a squared is going to be equal to b squared plus c squared. Now, if we were dealing with a pure right triangle, if this was 90 degrees, then a would be the hypotenuse and we would be done. This would be the Pythagorean theorem. But the law of cosines gives us an adjustment to the Pythagorean theorem so that we can do this for any arbitrary angle. So the law of cosines tells us a squared is going to be b squared plus c squared minus 2 times bc, 2 times bc times the cosine of theta. Times the cosine of theta. And this theta is the angle that opens up to the side that we care about. So we can use theta because we're looking for a. If they gave us another angle right over here, that's not the angle that we would use. We care about the angle that opens up into the side that we are going to solve for. So now let's solve for a, because we know what bc and theta actually are. So a squared is going to be equal to b squared. So it's going to be equal to 144 plus c squared, which is 81. So plus 81 minus 2 times b times c. So that's minus 2. I'll just write it out. Minus 2 times 12 times 9 times the cosine of 87 degrees. Cosine of 87 degrees. And this is going to be equal to, let's see, this is 225 minus, 12 times 9 is 108. 108 times 2 is 216 minus 216 times the cosine of 87 degrees. 87 degrees. Now let's get our calculator out in order to approximate this. And remember, this is a squared. Actually, before I get my calculator out, let's just solve for a. So a is just going to be the square root of this. So a is going to be equal to the square root of all of this business, which I can just copy and paste. It's going to be equal to the square root of that. So let me copy and paste it. So a is going to be equal to the square root of that, which we can now use the calculator to figure out. So let me increase this radical a little bit so that we make sure we're taking the square root of this whole thing. So let me get my calculator out. So I want to find the square root of 220. Actually, before I do that, let me just make sure I'm in degree mode, and I am in degree mode because we're obviously we're evaluating a trig function in degrees here. So that's fine. So let me exit. So it's going to be 225 minus 216 times cosine of 87 degrees, not 88 degrees, 87 degrees. And we deserve a drum roll now. This is going to be 14.61 or 14.618. If, say, we wanted to round to the nearest tenth just to get an approximation, it would be approximately 14.6. So A is approximately equal to 14.6, however, whatever units we're using, long.